I'm going to make you a promise. If you watch this entire video to the end, you will be able to decipher what this regex means. So, how does one become a regex gigachat? Let's go inside and find out. So let's start off simple. With regex, you can match literal characters. For example, in grep, when you search for a string, it's literally a regex, but you're just searching literal characters. So dog, for example, will match dog, as well as something like cat dog. And I'm using Rubula for this, by the way. Most regex is very similar. There are a few different flavors. For example, Vim uses something slightly different, but today we're going to cover a more general regex, which is going to apply to pretty much anything. So if you're searching for dog, as you see here, it matches the dog here and the dog in cat dog. If we search for cat, it will match the cat here and also the cat in cat dog. Next up, what if you want to reference the concept of any character? You use a period or a dot. This will match any character except a new line. So, for example, if we do C period T, again, it will match cat and cat here. C period T will match stuff like cat, set, CDT, cot, C underscore T. For example, we can do this, so it will match can. You can do this, and it will match for, but it will also match FIR in first, and F space R here, because of course period is just a placeholder for something, right? So FO period will match for, but it only matches one character. It doesn't apply to multiple characters. Next up, we have character classes. So now that we've covered the period, let's move on to character classes, which let you define a set or range of characters that can match a given position. So if we go back here, if we do ABC like this, what that will do is it will match any instance of the letter A, B, or C in our text. So as you can see here, it's highlighted all these letters, and it's important to point out that these are separate matches. So the C is a match, the A is a match, they're separate. We'll get into a second as to when that's not the case. Now, if we do 0 to 9, for example, it will match any digits separately. So it matched the zeros in look. Now next we can do something like this, where it matches all the capital letters in your string. And of course you can do all the lowercase letters as well. And if you want both, you do something like this. And now it matches every single letter, but not digits or symbols. Now if you want to, you can actually write this as shorthand like this, with capital A dash lowercase z. And it will do the exact same thing, although this does not work. It has to be capital first and then lowercase. Now, if we jump back here for a second. So what we can do, another example of this, would be, let's say we do TR, and then we do R, A, E, or U, and then D. So this will match trad, as you can see here, in tradwife. And the reason why is because what we're saying is match TR and then something and then D. And then the something here is vowels, right? So it will match trad, it will match tread, trid, trod, and trud. But it's important to point out that it will not match multiple. So it will not match treyud. It will only match one of the letters. By the way, I have a written version of this video on my GitHub. Right here, it's in guides. If you want to refresh your knowledge at any given point, maybe give the repo a little star to make me look more popular than I really am. Thanks. Let's get back to the video. Next up is quantifiers. So I'll show you how to control how many times characters can repeat. They apply to the character or group right before them. So this might not make sense right now, but I promise it will make sense in a second. So the first quantifier is asterisk, which allows for something to repeat 0 or more times. So we can have geo asterisk d. So for example, geo asterisk d will match words like God, good, good, and good. So for example, I'll show you. So it matches good, it matches and good with any number of O's, because the asterisk means it can be a word that starts with G, ends with D, and it has to have an O in the middle, and you can have as many O's as you want, and it will always match. Then we have the plus sign, which allows for 1 or more repetitions, but not 0. So for example, if we go back here, so we do geo plus d, we will match words like God, good, good, but not gd, because plus only allows for at least 1 repetition or more, and so 0 repetitions doesn't count, right? So for example, if we do good, God, but then gd doesn't get matched. Next up is question mark, which matches 0 or 1 time. So if we do geo question mark d, we don't have any matches, because it will match gd, God, but not good, as the O repeats more than once in the case of good. Finally, we have a range from m to n, which allows matches between m and n times. So how does that work? So you can have geo, let's say from 2 to 4, and then d, right? So this will match the following. It will match, so it won't match God, because we need to have a number of O's between 2 and 4. It will match good, it will match good, it will match good with 4 O's, but it won't match good with 5 O's because we are now again outside of the range. Next up is anchors. So anchors don't match characters, but instead they match positions in the string. So they can be used to specify where the pattern must appear in the text. The first anchor is the caret symbol, which matches the start of the string. This may sound weird, but it will make sense in a second. So if we go back to our text here, so if we do caret in like this, we're matching the in right here. However, if we do caret in, you might expect it to match the in right here, but it doesn't, because the caret says, hey, this has to be at the start of the string. And because it isn't, it doesn't actually find it. Now, just to clarify, in this case, what we're doing here, this isn't the string, these are 2 separate strings. Or at least this is how Rubular is interpreting it. And so we can also find dodos if we do that. Even though the context may be a bit different depending on how you're using regex and how you're manipulating the strings. So the opposite of caret is the $reno sign, which matches the end of the string. Because of that, so if we do so period $, this will match the so here at the end of the string. Now bear in mind that if you just did so, it would not match, because there is a period after the so. Now in this case, the period that we're putting here doesn't mean period. It's a placeholder for any one character. Because remember, we talked about this at the start of the video. So for example, if we go here and we do question mark, it still matches it, because this just means anything. If we wanted to make it into an actual period, so we're looking for SO period, we'd have to escape the period by doing a backslash. So if we go back here and we replace it with a period, boom, now it's matched. Notice how Vim also makes use of caret and $. I'm not currently in Vim, I'm using Obsidian for this, but I have Vim motions enabled. If you want to see a Vim, an Obsidian video, let me know and I'll make one. What do you think of this copyright nondescript Santa on this bottle of Norwegian milk, of Helmelk? Is that tough? I think so. Grouping and alternation. When it comes to grouping, parentheses allow you to treat multiple characters as a single unit. So what does that mean? So if we put something in parentheses like that, like dough, for example, it will match multiple instances of dough. So this is dough, dough, right? There's a dough in here. There's a dough in dog. However, if we add a little plus to it, then we get matches like dodo and do and dodo here. So these are no longer separate matches of individual doughs, but they're one match. And the reason why this is cool is because you can do stuff like this. So you can do cat or dog like this. It's finding cat, but it's also finding dog. And it's finding cat dog as well. So a normal character class will match any character inside its brackets. We covered this earlier with examples such as tr vowels d. On the other hand, a negated character class matches any character that is not a digit. So for example, we can do caret, say 0, like that, right? So what we're saying here is match anything that is not a digit. So in this case, it matched everything except for the digits. We can do like no lowercase vowels, because if you see here, it matched uppercase I. So you can do something like this if you didn't want to match any vowels. But as things are, it matches anything other than lowercase vowels. So it will match consonants, it will match uppercase vowels, and it will match symbols, space, new line, essentially everything else. So now that you understand the above, there are shorthands you can use so that you can type less. Let's have a look at some. So we're going to start off with backspace lowercase d, which matches any digit from 0 to 9 and is the equivalent of just parentheses 0 to 9 parentheses. So it matched the zeros. If we do d plus, it matches full numbers. So if you pay attention to the highlight below, the zeros are a bit spaced apart. If I do plus, they're together. This is because the lowercase d matches each digit independently, whereas the plus matches the number. So for example, if you could be using regex to programmatically extract each digit in a integer, right? You could use something like this. So you could use regex to extract every single separate digit and put it in an array, for example, or you can do this to extract any separate numbers that exist in your data. So now if we did capital D, this matches any non-digit, so any character that is not a number from 0 to 9. Now, capital D plus matches strings such as say, question mark, although really in this case it looks like it literally just matched just like the entire paragraph. So like this would be a match, this is another match, and then this is another match. So we'd have 3 separate matches in this case. Although it doesn't appear to have matched the new line here. Very interesting. So next up we have W, or lowercase w, matches any word character. So this covers the A to Z, uppercase and lowercase, 0 to 9, and also underscore. So if you want proof of that, there you go, underscore is also matched, but the question mark is not. To be specific, it actually matches every single character separately, right? So you could use this to break down a sentence or a word into its individual letters. However, if you do W plus, that then matches words. So you could use this regex pattern to extract words from a sentence. And the words are basically separated by space, punctuation, and I think dashes as well. So dodo, hi. Okay, interesting. So it includes underscores in the words. So if there's an underscore, it actually matches the full word, but if it is a dash, it treats them as 2 separate words. So now let's move on to uppercase W. So this matches any non-word characters, so most symbols, spaces, etc. So as you can see here, the spaces are highlighted, so is the new line. So if we have a bunch of punctuation, this punctuation is selected separately. However, if we do plus, the punctuation becomes one match, right? So for example, the question mark and the space become one match. So do these periods here. Because if you're doing this programmatically, sometimes you want to extract them individually, and sometimes you want to extract them as a whole unit. Next up is lowercase s. This matches any white space characters, so space, tab, and new line. So as you can see here, spaces are matched, same as the new line. However, as you can see by the highlighting, there are separate matches. However, if we do plus, then it matches multiple things in one go. So it will match two spaces here, for example. If we do capital S, it matches any non-white space character. So anything but space, tab, and new line. So as you can see here, every single element is its own thing. And if we do S plus, then it actually matches every single word, but it includes punctuation. So the so has its punctuation, there's a comma here after the plus. Again, which one you use depends on what you're trying to achieve in your particular example. Okay, so now let's revisit the regex pattern from the start of the video. Armed with this knowledge, I want you to pause the video and see if you can figure out what it does. Feel free to rewind and rewatch certain portions of the video first, if you need to. Have you figured it out? Okay, so let's go over it and we'll see what it does. I've also gone ahead and pasted two examples that match with this regex. So let's go through each element of it. Is this broken now? A little bit? That's fine. So we'll go through each element of this and we'll figure out why it matches these two sentences. So the first bit here is the caret, which means that the very first word in the string should be a hey space, actually. And this is matched right here. Then we have giga and mega in parentheses separated with pipe. If you remember from earlier, pipe just means or, which means that either giga or mega would trigger a match. You can use whichever one you want. Then you have a space, chad, comma, space, go, space, which are non-negotiable. Right, so these are present in both the matches. Then you have buy or purchase. So same concept as before. You get to do either buy or purchase. And both would match. Now here's where it gets a bit weird. So you have yourself, space, in parentheses, and then question mark. So what this means is that yourself in space afterwards can occur either one time or 0 times. So yourself space occurs one time here, so it matches, but it doesn't occur here, which is still a match, it's fine. The yourself is optional because it can either occur once or 0 times. Then we have lowercase d and then range from 2 to 5. So if you remember from earlier, this just means digits. And we can have a number of 2 digits, 3 digits, 4 digits, or 5 digits according to our range here. So for example, 33, that's 2 digits, so that's fine. 101 is 3 digits. And then 10,155 is still fine because it's up to 5 digits, but if we add one more, the regex no longer matches. The number is now too big. So then we have, now this one is one of my favorite bits of the regex. So what does this do? So we have do, so we have space in the word do, so it has to start with do. Now it can have either G or O in any combination in any order of a minimum 1 time and a maximum of 3 times, and then an S. So DOGS is fine because that matches the 1. And you can also have something like doggos, because of course it's DOGGO, that's 3 times, and then S. So you can spell it like that if you want to. Then we have space with space, that's a non-negotiable, so that appears in both. Then we have the or your, so like before, this is either the, so we have with your or the. Then we have based, which is of course non-negotiable. Then we have wife or trad wife, like that. And then we have period, and it's escaped. And of course, if we do question mark, for example, this will no longer match. Because the period is escaped, it means that it has to be a literal period. And then here's the funny bit. There's the $ at the end, which, if you recall, this means that this also has to be at the end. And so by having the caret at the start and the $ at the end, what this means is that this is the only thing that you're allowed to have in your string. If you do anything else after that, the regex will not match. So let me show you. If you remove this bit and we add some more text here, the high didn't match because there's no criteria for it to match, but this still matched. However, if we put the $ back in, you'll notice that the entire string did not match. And the reason is because what the $ is saying is, listen, if this is to match, the only thing that you're allowed to have in the string is what's in here. If this is the start of the string, this is the end of the string. If there's anything on either side, right? So if we have a little smiley face here at the start, well, this breaks the logic here. So now the entire sentence no longer matches. Now, we could go more complicated than this, but I think this is enough for today. If you'd like to delve even deeper into regex in order to increase the odds of landing your dream trad wife, also known as trad wife maxing, leave a comment down below and I might make a part 2 for this. Bye-bye.